Hi everybody! So in today's video, we're going to be learning about a new type of way to write the equation of a line. So we have a couple different goals for today's video. The first target is we are going to be practicing finding what are called the x and y intercepts when given an equation. So that's the first thing we're going to do. And the second part of today's lesson is going to be about graphing a linear function given an equation, a table, or a situation in context. So we're going to still be graphing our equations. We're just going to be doing it in a new way by looking at what are called the x and y intercepts. Let's start with this. So far this year, we've really focused on two types of equations of lines that we've called slope-intercept and point-slope form. Today, we're going to be learning a new type of an equation of a line, which is what's called standard form. Here's what standard form looks like. The standard form of an equation of a line should look like this: ax plus by equals c. Now, in this equation, the a, the b, and the c are just numbers. The x and the y are variables. So an example of this type of equation would look like this: 3x plus 4y equals 7. There are a couple features of standard form. So kind of what makes this standard form? What does it look like that tells us that this is standard form? The first feature is that both the x and the y terms should be on the same side of the equation. So you'll notice that in this equation, the x term and the y term are both on the left side of the equal sign. The second important feature of standard form is that there are no fractions allowed. So unlike the other equations that we've been looking at, a standard form equation will never have fractions in it. When we are graphing a line and the equation is written in standard form, instead of using the slope and a starting point, we're going to use two key features. We're going to use the x-intercept and the y-intercept of the line. So the next part of our notes, what we're going to do is review what the x and y intercept of an equation of a graph are, and then we will practice actually finding the x and y intercepts and using those to make the graph of a line. So let's review. Earlier this year, in Module 3, we learned about what are called the x and the y intercepts. The x-intercept is the location on a graph where the graph crosses the x-axis. On this picture, the x-intercept would be right here because that is the place where the line crosses the x-axis. Now, the coordinates of that point would be the point 3, 0. When we write the coordinates of the point of an x-intercept, the y-coordinate is always 0. So you'll notice in this ordered pair, the x is the number 3 and the y is a 0. The y-intercept of a graph is the place where the graph crosses the y-axis. Now we use the y-intercept many times to make the graph of a line. In this graph, it would be right here. The coordinates of that point would be the point 0, 2. In the coordinates of a point for the y-intercept, the x-coordinate is always 0. So if I were to list this information, the y-intercept would be 0, 2, and the x-intercept would be 3, 0. I remember this information in which coordinate is 0 by always thinking if I'm looking for the y-intercept, then the y is the number, the 2, and the x is the 0. If I'm looking for the x-intercept, then the x is the number and the y is the 0. So whichever intercept it is, That tells me which part of the ordered pair is the number that I'm looking for. Now we can use that to help us find x and y intercepts when we're given a graph. So the x-intercept of this graph would be the place where the graph crosses the x-axis. That would be the ordered pair 1, 0. The y-intercept of this graph would be the place where the graph crosses the y-axis, which would be the point 0, -2. For the next problem, the x-intercept would still be the point 1, 0, and the y-intercept would be the point 0, 3. When we're given an equation, we can find the x and y-intercept using what we know about the ordered pairs. For example, I know that in my ordered pair for an x-intercept, the y will be 0. And I know that in my ordered pair for the y-intercept, the x is 0. So I like to write that next to the ordered pair to remind myself that if it's the x-intercept, then y is 0. And if it's the y-intercept, then x is 0. Here's how we can use that to help us. If we want to find the x-intercept, we're going to do this in 2 steps. We'll find the x first. Then we're going to take a y of 0 and plug it into our equation. So in this equation, I'm going to copy the 2x plus 7, and I'm going to replace the y with 0, equals 28. Now I can solve. So 7 times 0 is 0, which means I get 2x equals 28. If I solve this, I would divide by 2 on both sides, and I would get x equals 14. So the x would be 14, and the y would be 0. Now, if I want to find the y-intercept, then the x in my equation would become 0. So that same equation I used before, I would write 2, and then instead of x, I would fill in 0 plus 7y equals 28. Now 2 times 0 is 0, so I would get 7y equals 28. If I divide by 7 on both sides, I can solve this equation and figure out that y should be 4. So in my ordered pair, I would make the y coordinate 4. Now, I would consider this kind of the long way of finding an x and y intercept, but we do have a shortcut. The shortcut is what I like to call the cover-up method. Now, for this shortcut to work, you're going to need to cover up part of the equation. So here's how we do this. If we look at problem 4 and we want to find the x-intercept, if you want to find the x, you cover up the y. So with my pinky, I'm going to cover up the 2y. The new equation that I see says 3x equals 6. Now, in my mind, I know that to solve that, I just need to divide. So if I divide by 3, I would get 6 divided by 3 makes 2, which means my ordered pair would be 2, 0. Now, to find the y-intercept, we would cover the x. So with my pinky, I would cover the 3x. I see 2y equals 6. In order to solve this, I would divide by 2 to undo the multiplication. And 6 divided by 2 makes 3. So in my ordered pair, the y would be 3. Now let's go ahead and skip over to number 6. We'll skip number 5 for now, and we'll talk about number 6, and maybe we'll do number 5 as an extra practice problem in class tomorrow. So again, to find the x-intercept, you cover up the y. So with my pinky, I'm going to cover up the 5y. I see negative 3x equals negative 15. To solve this, I would divide by negative 3 on both sides. So my answer would be 5. So I would get the ordered pair 5, 0. To find the y-intercept, I would cover up the x. So with my pinky, I would cover up the negative 3x. I would divide by 5 on both sides, and I would get 0, negative 3. All right, now how do we use this to make a graph? Well, if we've got an equation that looks like this, which is what we called standard form, then instead of using a starting point and a slope to make the graph, we're always going to use the key features, the x and the y-intercept. To find the x-intercept, we're going to cover up the y. So I would cover up the 2y, and it just says x equals 4. So I would get 4, 0. To find the y-intercept, I would cover up the x, which means I have 2y equals 4. If I divide by 2 on both sides, I get 0, 2. So to make the graph, I would graph the point 4, 0. I would graph the point 0, 2, and I would draw a line connecting the dots, and that's how I would make my graph. For problem number 8, which is also standard form, to find the x-intercept, I would cover the y, which means I would have negative 2x equals 2. If I divide, I would get negative 1. To find the y-intercept, I would cover up the x. And when I divide, I would get negative 2, and I would divide by negative 2, I would get negative 1. So the 2 points on my graph would be negative 1, 0, and 0, negative 1. Then I would use my straight edge and just connect the dots, and that's how I would draw my line. All right, thank you guys so much for watching. Have a lovely afternoon, and I'll see you for some practice in class.